Right, okay, so let's give this question 8 a go. Well done if you've managed to get this far. So we've got a raindrop looking thing. We've got a vertical cross section, so that means we're looking at it standing up. Or a child's spinning top. I want to Google one of those is, just get a bit of a picture of what they are. You'll know what it is when you see it. Point A is like, yeah, okay. Line CD is perpendicular. Maximum distance, yeah, okay, it's probably some diagram. Spinning top's given by that. Where part of the curve is rotated through above the initial line. Show the surface area is given by that. And then we're going to want to find the length of CD. Okay, 13 marks. Not a lot of information just given to get started. So, first let's get surface area. We're going to need surface area equation, which can be formula booklet here. We need to get which parts of the curve that we've got. And it might be, I think it might be worth us plotting what this graph's going to look like. With any polar curve, so if we've got r squared is 25 cos 2 theta. Any curve, it's worth us, especially polar ones, it is worth plotting them to get a sense of where they are. When I'm plotting them, I think it makes quite a bit of sense, depending on how comfortable we are these things, to plot them in degrees. So we'll do 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees. I'm not going to do anything past that because it's an r squared, the square root would give plus or minus. So that would give us the top sort of part and bottom part. So when I'm looking past 180, the negative y-axis, so it's going to be given plus or minus, so we'll get that symmetry from that. Let's put those values in. Got 25 cos 2 times 0, and I'm square rooting this straight away. So I get 5 there. Just make sure your calculator's in degrees mode if you're doing it this way, or if you're doing it properly, then that you've got it in radians mode. It's 30 degrees, that's 5 root 2 over 2, about 3.5. 45, it's 0. 60 degrees, I get an error. 90 degrees, also looking at an error. 120, error. 135 and 0. 150, getting 3.5, the 5 root 2 over 2, 1 again. And then when we've got 180, getting 5. So I'll be maths professors at uni, getting very annoyed if I use degrees there. So we can now start to think about what this graph's going to look like. Okay, so we've got our x-axis, y-axis. So when we're at 0 degrees, we're at 5, which is the maximum distance. 30 degrees, we're at about 3.5, so we'll say about there. And it would be same this way because it's the distance and because of the square term. So I don't know if it's plus or minus. At 45 degrees, we're going to be at 0. I can't really do much on that bit. It might help to draw that. Got a rough idea of that line on there. Yeah, probably the same for not great. Start, so I didn't draw a line on one of these little tablet things to write on. That's well, like that. So that should show my 45 degree lines. If you're a general relativity physicist, and these mean quite a lot to you. So then 45 degrees, 0, 60 degrees, error, 60 to 120, 100, 135 we're back here. So this is looking like a no-go zone. Okay, and then 135 we've got 0, and then 150 we're getting that same value there, which means the same value here, and then we're reaching back out to 5. So in terms of a curve, we're starting here, going there, and then we're reaching out to 0, so it's got something like that. And then we're coming back out like that, and back down, like that, and we're going to reach towards 0, and towards the origin should really be the same. Something like that. So that's going to be our polar curve. That's our equation, r squared. It looks like we kind of missed out something, just assume there, got another no-go, don't worry. No. So that's r squared is 25 cos 2 theta. Now, one thing to just immediately notice is that this is rotated compared to this diagram here. And, well, first of all, we've got half of curve. Okay. I was doing that. Oh, it's because I moved the background rather than the actual. Yeah. Sorry about that. I'm dragging the picture on the page rather than the actual moving the background. So you can see it's got one sort of bulb or one part of the infinity bit, and then yeah, it's rotated. So we might need to mix up what we think of x and what we think of as y. This one. If I just grab let's get back to the actual question that we need. So I want to evaluate the surface area, which I'm going to integrate between formula gives us alpha and beta, and it's 2 pi, which I think comes out, I'll put it out at the front, actually. No, I tend to find it easier being at the front. R sine theta, so I'm going to write that at the front. 2 pi integral between alpha and beta, r sine theta times the square root of r squared plus dr by d theta squared d theta. So we need to think about our values that we've got. Going to integrate in between and actually working out some things. So I'm still thinking about the integration, just half in the back of my head while I'm doing this. But I think we should now just actually try and get on with the formula a bit when my laptop stops playing up. Alright, it's really annoying. So we've got r squared. So got that value. We need dr d theta and we need r. So let's try and differentiate it. So we've got r squared is 25 cos 2 theta, and differentiate. I'm going to differentiate implicitly here. And that's going to give me minus 50 sine 2 theta. So that we can get my dr by d theta right by 2, so that's going to give minus 25 sine 2 theta all over r. I could put what r is, but I'm not going to bother because I'm going to square it in a moment anyway. Be very careful here to not make a substitution. We are putting the derivative into the formula. A few people in the past, and myself included, made the error where we try and read it for dr or d theta and substitute it in. We're trying to work this bit out. So we've got 2 pi times the integral between alpha and beta. And actually, rather than worrying about the integral bit, let's just work out what the integrand, the bit inside it would be. So I've got r sine theta. So this is the bit inside the integral is called the integrand. Sometimes it's a bit nicer just to work that bit out. rather than copying down integral signs loads of times worrying about your notation. So r squared we've got is 25 cos 2 theta, and then the square of that is going to be 25 squared sine squared 2 theta all divided by r squared, which will be 25 cos 2 theta, not cos 2 theta squared, d theta. Yeah. So let's carry on with that. So we've got r sine theta square root, let's sort of spit out a little bit. So I've got 25 cos 2 theta is 25 sine squared 2 theta all over cos 2 theta. Okay, so what can we then do with our integrand? Okay, I've got this r on the outside, which I probably shouldn't use. Now, if I bring the r inside the square root, that means I'm multiplying by r squared. So I'll leave the sine theta on the outside. And I've then got on the I've then got on the inside is going to be r squared times that. Actually, I might be helpful. No, keep it as is. So r squared was 25 cos 2 theta, so that's this bit now. So I've got 25 squared cos squared 2 theta plus, now I'm timesing this bit by r squared, so I'm going to have 25 squared sine squared 2 theta cos 2 theta all over cos 2 theta. Again, it's not squared here, it's squared here because we already had a cos 2 theta. So then we've got sine theta, and you can see that's when it starts to cancel. So I'm going to go, and I've got 25 squared, and I'm just left with the infamous cos squared plus sine squared. So square root of 25 squared is 5, so that's just going to be equal to 5 sine theta. So the surface area now, that was 2 pi integral of 5 sine theta within our limits of integration. Now, in terms of what values we're integrating between, I've got to my plot. R is 0 here. I've got the plus and minus here, but we've got to again remember it's the whole thing's rotated. Now we need to think about which values are we rotating about. So let's say I think of this is our x-axis, I guess, although again it's kind of inverted. This is our y-axis. We're going to rotate around this axis. So we're rotating 2 pi range about the axis, that's already defined. We just need to think about which parts of the curve that we need to do that. Now, if you look at the way that I've drawn it here, and it doesn't matter if I draw it to the x or the y axis, we're using half of the spinning top. In other words, we've got r is 0 at that bit. And where did we have? So that we could count that as r is 0, and the other one, so I could set r as 0, and this would be pi over 4. Remember, it's making a sort of infinity-like shape. That's very bad. continuation of that, but actually go through the title. So, thinking very carefully here about which bits to do, and say it should really be drawing about the x-axis. It doesn't say that it's about the y-axis, it just says about the initial line that they've got there. So think of it being rotated. So you can think of the picture being like that, but still rotating 2 pi radians about that axis. But the key thing is that, sorry, it's not r, it's theta. It's going to vary between those to give us those parts of the curve. So thinking between 0 and pi over 4. So the integral then is going to become 2 pi, and it'll be minus 5 cos sine integrates negative between pi over 4 and 0, which is going to be 2 pi, I'll write it now as 10 pi, and what we're going to have, we'd have cos of 0 minus cos pi over 4. If you've got a minus, it just needs to do the limits the other way around. Now we know that cos of 0 is 1, cos pi over 4, one of those values that you probably should know, but I don't. Cos pi over 4, I've got drawing graphs, so that's root 2 over 2. So that's our value. We just need to now show it in a particular form, which is k pi 2 minus root 2. So it's k pi 2 minus root 2. So it's telling us to combine the fraction. So I'm going to get 5 pi. I'm going to factorise out half, basically. 2 minus root 2. That's centimetres square area. So k is going to be 5. Okay, so that is our surface area done. And it says now, show that according to the model, the length CD is 5 root 2 divided by 2. So, we're looking at this distance here that we want to calculate. Now, what we do know at these points is that we've got a maximum y coordinate. Okay, because remember the things on its side. So I've drawn the axes like this. So we've got our maximum y ordinate. How do we get a maximum? That's when we've solved the derivative equals 0. So we need to look at solving that. So just to remind for myself, so we've got r squared, 25 cos 2 theta, and we want to find the value of dy d theta. You might ask, where does y come into this? Well, x is r cos theta, y is equal to r sine theta. So dy by d theta, going to be a product rule here. So if I differentiate r, I'm going to get dr d theta, so that's going to be sine theta dr d theta. Plus, if I differentiate, that's if I differentiate r, if I differentiate sine, I'm going to get cos theta times r. So cos theta will go up a bit, wouldn't it? So we just need to substitute our dr by d theta in, which we did work out earlier. So dr d theta, just scroll to find what it was. Is minus 25 sine 2 theta over r. Minus 25 sine 2 theta over r. It's not the best way to write it, but because we've got the r in, we're going to work that out in a moment. So I've got dy by d theta going to be equal to minus 25 sine theta sine 2 theta all over r plus r cos theta, which is going to be 0 at a maximum. So then let's rearrange our equation a little bit. So I'm going to get rid of that r denominator. Minus 25 sine theta sine 2 theta plus r squared cos theta is going to equal 0. And then we know what r squared is, so let's have a look. So we've got minus 25 sine theta sine 2 theta plus 25 cos 2 theta cos theta, which equals 0. Now let's rearrange. Cautious if we want to divide anything, so it might be worth trying to factorise or get this in all in terms of one variable. So let's remember our double formula identities. So sine 2 theta is 2 sine theta cos theta. That'd give us a cos theta in common, which I could factorise out. And the rest of it is probably worth getting in terms of sine. So cos 2 theta, that's 2 cos squared, that's cos squared minus sine squared. It's 1 minus 2 sine squared. So I've got minus 25 sine theta times 2 sine theta cosine theta plus 25 1 minus 2 sine squared theta cos theta. That's going to equal 0. I'm going to factor out a cos theta from the whole thing. And what we're left with, well, I'm going to have minus 50 sine squared here. 25 there, and I'm going to have a 50 sine squared theta there, and sorry, that's a minus in there. That's going to equal 0. So then we've got cos theta brackets, we've got minus 100 sine squared theta plus 25 equals 0. I could times everything by minus 1 just to make that look a bit nicer in the bracket. So we'll have 100 sine squared theta minus 25, and actually divide it by 25. So that would give me 4 there, that would give me 1 there. Right, here what I can do, so I've got cos theta brackets, it's the difference of 2 squares that we've then got there. That equals 0, so we just need to find the values when each bracket equals 0. So cos theta equals 0. Well, we've got sine theta, the half from that one, sine theta minus a half from that one. Now it's the, appears to me anyway, it looks like it's the first time the y value would equal 0. Sorry, with first maximum value we then get a maximum the next repeat. So we're looking for the smallest value of theta, because we kind of define it to be like that. So when is cos equals 0, when is pi over 2, 3 pi over 2, etc. Yeah, that's probably not going to give us the value that we need. But we are going to look at sine, so we'll do inverse sine of a half. I get pi over 6. Pi would be pi minus, so I'd get 5 pi over 6. Another one, and so on. Whenever I do these, I always put the values in just to check, and then the sign for minus a half is just going to give us the minus of all those. Okay, so let's check the values. So our smallest value that we've got is pi over 6. Right, so, and that's going to be our two values because we've got a positive one and we've got got one on the right and one on the left, haven't we? So remembering that x was sorry, y. I'll use x above. Yeah, y is our sine theta. And we're choosing theta is pi over 6. So r squared was 25 cos 2 theta, and sine pi over 6 we can work out. That gives us a half, which I should have realised from the question. So our r squared is 25 cos pi over 3. So when I get the r here, I'm really getting the plus or minus 5 times the root of cos pi over 3. So square root of 25 cos pi over 3, and that's going to give plus or minus 5 root 2 over 2. That's that value we saw before when we were plotting it, actually, which makes sense. So it means that I plotted the graph slightly wrong though. So it's a maximum here, so it curves in straight away after that point, based off that info that we just had. Otherwise, I'm looking at this point where I'm getting the maximum distance between them. Okay, so that's the r value. I could then put that into each of the y's, but that's so I get the y value. One of the y values, the positive one, would be a half of that, 5 root 2 to 4. The other value would be minus that. But what I want to find is the maximum distance, which is CD, which you can say is y1 minus y2. So I'm taking them away. Should just give me 5 root 2 or 2, I think. But always be cautious. Plus 5 root 2, 4, and indeed it does. 5 root 2 over 2. That's our maximum value for CD, which I don't really have a way checking apart from making sure I know the values like that. But at this point, I'd kind of prioritise checking other things to make sure. Of course, we want to make sure our units, CDs are length, is in centimetres. Okay, I hope that's been helpful, as well as the videos going through the other questions. If you do have any questions yourself, feel free to let me know. And best of luck with any exam revision that you have. Take care now.